Welcome to Connected, Automated, Electric, a podcast series brought to you by the National Electric Vehicle Consortium. You will hear experts from industry, agencies, and academia describe the broad spectrum of technologies that comprise the EV sector with a particular focus on preparing the skilled technical workforce. These technicians work in all of the EV sectors, including manufacturing, operations, system installation, and charging infrastructure. I'm your host, Mike Lisecki, and let me remind you that the opinions expressed do not necessarily reflect the views of our sponsor, the National Science Foundation. Our guest today is Mike Beebe. Welcome, Mike. Tell us a little bit about yourself, your background, and what you're doing today.
Okay, well, thanks, Mike. Thanks for having me. I'm part of the National Electric Vehicle Consortium here, and one of the things I did today was to do some light electric vehicle training. What I've done for 50 years now is been in engineering and in the automotive sector, and one of my main emphasis has been automotive safety, and that lies around all sorts of things: crash testing, design crash test dummies. I've also been head of the Electric Vehicle Safety Committee for Society of Automotive Engineers back in the 90s when we were first going through some of these standards and trying to understand what to do. I helped write the federal vehicle standard for the electric vehicle crash testing that was developed in the 90s. I've worked on electric bikes since the 90s. I've built electric cars since 1980. And so I've always been in that area of the technology, but also how to make it safe and how to train people on how to use the technology effectively.
Do you teach? Are you teaching now, Mike?
Yes, I've been an engineer, but I gradually moved into teaching over the last 12 years. I did it part-time as an adjunct. The last 7 years, I've been a full-time adjunct in mechanical engineering at North Central State College in Ohio.
Great. Now, I have to ask you this, Mike. You mentioned light electric vehicles. Sometimes people don't understand when you transition from a vehicle to a light electrical vehicle. Is there some dividing line that defines that?
Yeah, I mean, light electric vehicles first thing you would think of is golf cart.
Yeah, sure.
Golf cart is a light electric vehicle, been around for decades. Now, with the advent of electric or lithium batteries, you've opened the door to like electric bicycles, the electric three-wheelers. Since the battery's gone down in size and weight, you've been able to do things we couldn't do just several years ago. A light electric vehicle is usually around less than 1,000 pounds, somewhere in that neighborhood. There's a whole class of neighborhood electric vehicle that's certified or not certified, but defined by the National Highway Traffic Safety Administration that is 25 mile an hour or less. And they're more like a high-performance golf cart from the standpoint of hydraulic brakes and all that. So we're seeing a new class of vehicles in a light electric vehicle all across the world. They are small, they're lightweight, and they're able to work in communities, small communities. Bicycles obviously more. So that's gained popularity and grown a lot. And they expect that classification to grow even more in the future.
You know, from your perspective, and by the way, I want to talk about safety in a few minutes, but let me ask you this first. From your perspective, now this long history of working in the field, what drives the development of electric vehicle technology today? Is it driven by price? Is it driven by government mandate? Is it driven by technology? What's your take? What drives that sector?
Yeah, that's a really good question because I've been through several cycles. Back in the 70s, when the first wave of actually manufactured electric vehicles, like with City Car, that was designed and built here in Florida, they were reacting to emissions and being able to make something because of fuel shortage and things like that.
Yeah.
Then we had the 80s come around, and there was a momentum yet from the fuel crisis and emission controls. And there were several manufacturers working on. I actually was building electric vehicles back in 1980 through 82, where we converted cars. And so the motivation was simplicity. People liked the simplicity, but they wanted to get away from the high gas mileage, high gas prices.
Right.
And then that kind of went into a lull in the late 80s. Then it came back in the 90s for this similar kind of reason, high price, the emissions, and California's initiatives.
Yeah, sure.
That really pushed everybody to move that. The solar car racing started. That got people's interest. Electric bike racing actually started then. We were doing some of that way back in the 90s or 80s. And then from there, it slowed down again till we got to the last several years, where now with Tesla and all the rest have been motivated saying, we can really do this now.
Yeah.
We were lead acid before.
Yeah, sure.
Everyone understood the technology because it was in everybody's car. And now we were able to demonstrate, I think EV1 did it first, where they demonstrated the high acceleration rate.
Yeah.
And now with Tesla and other manufacturers showing that you can really make high acceleration, and the battery is somewhat smaller, that's motivating people to say, I think I could really use these. And I think that's part of it. The other part is certainly government intervention, where you can put up the charging stations and motivating people to do that.
Yeah.
And Europe and Asia is also very motivated for the similar kinds of reasons. And with all that motivation, it created a large enough volume. And so it's motivating all companies, I think, to look at it a little closely, because you might be able to sell more than you could in the 90s, early 2000s, and that kind of thing.
Okay, that makes sense. You know, our listeners, Mike, many of them are involved in technical education, either students in community college programs or sometimes workers that are employed wanting to upskill. And my particular question for you today is safety. What should these aspiring technicians or existing technicians, what should they know, what should they be able to do or perhaps protect when it comes to safety? What are the safety issues around EVs?
EVs, when you say electric, yeah, that has always been stay away. I'm going to get hurt. All mechanical people, whether it's a golf cart or whatever it was, electrical was no. I don't want to deal with that. That's somebody else's issue. I think what happens is, as soon as you start, the first step is to understand it is no different in a lot of ways than something simple like a golf cart. There are certain things that people have to understand, and that's really the battery. I mean, everything else, they've seen motors, they've seen controllers, they've seen cars. It comes down to is how do I handle that mystery of a battery? First is chemistry. There are things that could spill, more so in years ago with lead acid. But the voltage, I think, is the most critical portion of how people view it, how they want to be safe around it. So if you know you get those crazy electrocution voltages. Yeah. I mean, an interesting story was back in the 90s, we were doing this electric vehicle safety development. And one of the things that our committee saw worldwide, if you put electric on the outside, the rate of theft of those vehicles went way down.
Interesting.
For the same reason that I'm going to get hurt. Mm-hmm. But I think, and another story of this was I crash tested the EV1 and several other vehicles back, and I was working for the National Highway Traffic Safety Administration, and I was the first to crash them for this next generation of stuff. And to give you an idea, none of the technicians would go to the vehicle after the crash. Not one. They made fun of me to say, you're the engineer in this program, you go touch it. If you don't you get shocked, then we'll come. And so what it was is I had to just train them on what to think about.
Yeah.
And that's really what we're doing now is don't do this and this, don't touch across here, measure here, keep yourself safe. Yeah. Make sure you understand the voltage and where it is in the vehicle. And that's why the orange wires came up.
Sure.
I mean, we did that as part of the SAE, standardized orange is high voltage. So don't cut across it, don't do certain things. But I think if you get really familiar with every technician I've trained on the basic safety of EVs is knowing that voltage is lethal. It could be. Don't get across it. Maybe put your hand in your pocket while you're working on things. You're a lot like electricians. I mean, the safety is very similar to electricians. You maybe cover the end of the tool with tape so you don't drop it and get across things. But the basic, just getting over that fear of the voltage is there. You can't see it.
Yes, right.
I think that's probably the biggest thing. It's like welding. People are scared to weld because it's electrical.
Yeah.
And as soon as you get them to understand that's not going to hurt you, put your hand across it and move forward, then they feel comfortable and they start learning really quick. And that's what I've seen with EVs. If you don't put your hand across here, or put your hand across there, put this hand across here, take a measurement across there. Did it hurt you? No. And I think that's where the gloves and the safety glasses and all the other things that are part of it are standard with a lot of different things. It's just getting over the fear of what electricity is because I can't see it.
Yep.
So to me, that's always been the making people comfortable with them.
You just remind me of an interesting story, Mike. When I was working in the semiconductor manufacturing industry, one of the high voltage things there's a thing called an ion implanter, which uses a pretty high voltage, kilovolts. Mm-hmm. And so as I was working with the technicians on this, I had them use their left hand to do some measurements. And they said, well, why my left hand? I said, so that's when your arm gets damaged, you won't have to retrain yourself to write. And did they look at me in a funny way. And what I was trying to do was to give them that sense of the seriousness of looking at it. And you mentioned putting your thumb in your belt, and that's a standard thing. Little things like that, I think we can help our students understand safety. What about in community colleges today? If I'm teaching in a program, how can I best bring in safety? Is there a safety course? Do I integrate safety into every one of my courses? Is there a certification? Several different questions there.
I guess yes to all. Okay. In a sense, the fact that the first day you're talking about the same things you're talking about, how to approach a vehicle, how to measure, how to make sure you are aware and you feel comfortable with these. And it's the personal protection devices.
Sure, the PPE.
I mean, you do that every time on whether it's a gas car, electric car, it doesn't really matter. But as long as you have the PPE right and you talk about what the safety standards should be in terms of how you approach it, what kind of safeguards you put in. You disconnect the batteries. You make sure you measure here and here. Make sure the capacitor is now depleted. Mm-hmm. All those things are built in lots of the vehicles, but you're double checking it to make sure it's a safe environment. No different than if I'm going to put a new plug in the wall.
Yeah.
You go turn the fuse box off.
And then you check the plug.
It's no different. And so that's where we start in with the students I have, is that's where we start. And then as they get into it and see that they can get comfortable with it, if you still go through the safety, just to make sure everybody's still using what they need to do. And if they aren't doing it, you just say, don't do that.
Mike, what about, I mentioned certification. Is there certification in a safety sense? Maybe I was reading something about the charging infrastructure, that people that are installing the charging systems, they need certain certifications, but I'm not so sure about that myself.
Well, there's different groups doing work on this. I mean, back in the 90s, we did something for I did training for first responders, junkyard groups, all that, and gave them a review of safety so they knew how to handle what they're coming in. Yeah. Same thing's going on now, like the Automotive Service Excellence Group.
Yeah.
They've got 2 tests you take that are high voltage safety, that you can get a certificate for taking those. And they've got a layout of what all's in there to study. And it's quite complete.
Yeah.
There's also SAE, Society of Automotive Engineers, have courses. In fact, I took one of them to see what it was. It was a high voltage class.
Yeah.
And you did it online. You got a certificate. It's basically talking the same kind of things that we're just talking about. Disconnect, measure, verify, so that you're as safe as you possibly be. And even when you get the pack open, measure, remeasure, make sure you have one hand in the pocket, all that kind of thing. Yeah. So there's those kind of certificates from SAE, ASE. There's been several groups now, like in Texas or Florida or wherever, they're going around doing first responders, and California was leading that charge. And so they got a chance to look at safety after a crash.
Yeah.
There's been issues where the first responders there's been a lot of states and things doing certification.
The lithium stuff.
Lithium, UL. Is now involved with that. UL is writing standards or working with the electric bike manufacturers, because the city of New York talked to the Consumer Product Safety Group, and they did not want any more electric bikes in the city of New York.
I heard about that.
Yeah, without UL stamp on it, because there's lots of different things made without UL, and they were having fire problems. So I think that encompasses a lot of possibilities that people can go out and get certified, or at least take a test or get training online even about electric vehicle safety.
So what's your advice? I'm a community college faculty. Should I take one of these online courses myself? Because you know how it is. I want to make sure I'm talking about the right stuff in my classroom. Maybe I should take one of these courses to bring myself up to speed. Does that make sense?
Absolutely, I did. I mean, I've got a degree in electric vehicles from years ago, but the technology changes. The kinds of things we have in the vehicle changes. So I always take the latest one. So I make sure I'm giving the students the best and up-to-date information.
Okay, that makes a lot of sense. I think that gives faculty the confidence also to get in front of their group of students, in front of their learners, and say, there's some new changes in certification standards or electric standards for this aspect, and here's what we're going to talk about today. I think that's a good approach. I think the very last thing that I'd like you to do is gaze into your crystal ball. Let's say it like that. Look out there in the future, maybe 2045. How does that sound? What do you see for electric vehicles today? Not only the safety aspect, but will they dominate our life at that point, or will it take longer than that? What's your vision?
Well, I'm an advocate. So my viewpoint's going to be, I'd like to see it take over everything. I've been working on EVs for 40 years. But I think in reality, there's several factors out there. One is the fact of the battery technology. I mean, if fuel cells, metal air batteries, supercapacitors, those all have a role to play that could change exactly how EVs are built, designed, and maybe more universal use. I think that's going to drive a lot of it. I think this mini size or micro mobility is going to grow rapidly by then. I think people have gone from when we first showed electric bikes to people, that's cheating, to this is really viable. And I think the same people like me, it got older, it's more usable. And in a way, it's nice to have. And I think the culture, as the students now we have, or in 2045, they'll think it's just part of what we do.
Sure.
And so I think that learning curve that we're going through right now with all the people, young people learning about, that's going to be what they want. I think it's going to come down to is how well we manage battery replacement, how we manage recycling, how we make it easy. You know, the chargers and all that stuff. The easier we make it, the more it's going to be adapted.
That makes sense.
I think battery swapping in some countries are already going. If you look at India, you look at Southeast Asia, the scooters are they're proliferating, the electric scooters, but they have not charging stations. They got batteries that you pull out and plug in. And in China, they have battery swapping for the whole cars. But I think the other thing that's going to drive it or get people saying, why not, is they're buying electric lawnmowers. I mean, right now, you're buying electric lawnmowers, you got electric bikes, you got electric scooters, and no one feels any concern about range. They don't concern about the technology, and it's packaged well. Like if you look at the lawnmowers, you've got those 60-volt, 80-volt plug-in modules, and they're nice packaged. They don't have any exposed connectors. You can slide it in, you go. You pull it out, you slide it in a charger, you go. You swap in batteries. I think those kind of things will build the business because people will be just so used to it. I got battery in my garage. I use it all the time. It's great. And then where's my car? I think the other thing is going to be price. If they can bring the price down, that's going to open up the next market to the people who are driving the lawnmowers and electric bikes. I want a car, but I can't really afford some of what's out there right now.
That makes sense. Well, Mike, on behalf of the National Electric Vehicle Consortium, I just want to thank you for your time today. Your insights were great. Your experience just outstanding here. So thank you.
I appreciate that, Mike. Thank you very much.
As we wrap up today, I encourage you to look into our show notes for additional resources. If you're interested in networking with academic, industry, and agency peers in the EV sector, and participating in meetings, grant opportunities, and technical publications, join our LinkedIn group. See the information in the show notes for that. And remember, connected, automated, electric.